Expanding dicratic phonetically. Expanding dicratics phonetically. The English alphabet contain phonetics as phonetics, which is how you sound words out. Phonetics is about sounding words out, but you got phonetics in all languages. The English language is known for accents. French is a phonetic language. In CBD is a dicratic language because it's phonetic and non-colonial dicratic language. It's phonetic to Igbo is phonetic, yes, because it's how to sound words out, how you sound words out. What am I referring to? I'm gonna say it in layman's terms. Phonetics. I'm trying to expand dicratic. Expanding dicratics phonetically. Implement a Markov chain that sounds word out to dictate the next word that did no implement dicratic phonetic implement a phonetic system machine learning model that takes speech to text and sound words out with the relative punctuation using this model. Expanded dicratics. Dicratics are tonal. Dicratics are tonal. For example, fe, fe, for fish, or modern day word facts, fish, ph it's pronounced for fact and for fish. Or modern day GIF, GIF or GIF. Is it GIF? It's GIF. Why is it GIF? Because the I and F GIF in English, the accent is not there. So we have I will pronounce it let me take my term GIF or GIF. GIF. Why GIF? Because the phonetics still holds. The phonetics of PHGIF, GIF. Holds as GIF, not GIF. Because GIF will mean the phonetic has been compressed. And compressing a phonetic is wrong because unless you're sounding the words out, so there is no accent. Oh, wait, is there an accent on it? No, English, no. Both are grammatically correct. So GIF and GIF are correct in English. But when you have in English, it will be incorrect. Because in English, let's go English. GIF or GIF? GIF. This is a very simple question. GIF or GIF? I said my last time GIF or GIF. I said GIF. GIF. So it's GIF. Why GIF? Or G, G, G. So what's the phonetic spelling of G? Ga, go. Oh, the phonetics of G are base A, B, C, D, E, F, G, G. GIF, not GIF, not GIF, because that's a J. Oh, it is GIF. Uh, it is GIF because GIF is pronounced good, 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 like go, 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 GIF, GIF, GIF. So it's pronounced GIF, not GIF, because G is you hold the GIF and the GIF represents the phonetic alphabet used to pronounce the GIPH. So, GIF into one word as one word. So, the machine learning, the Markov chain shall be used to implement the next phonetic alphabets and dictate what has been said ahead of time. Am I talking about one word, GIF or GIF? So if I implement a Markov chain, this will predict the next word by by looking ahead at the previous probability of words, probability distribution of the word, uh, GIF or GIF, which will form the grammar such that there is no which will form the grammar as one simple terminology or give the whole word. So in Igbo, GIF, be, say, they, in Igbo, or let me, that's French. In French, to be be, say, they, f, g. Sorry about that. My charger keeps dropping. B, say, they, f, g. F, A, B, C, D, F, G, A, J, J, K, L, M, N, P, Q, R, S, T, U, V, W, G, Greek, Y, Z, X, Y, Z, A, B, C, D, E, F, A, B, C, D, E, F, G, A, J, J, K, L, M, N, P, Q, R, S, T, U, V, W, X, Y, Z. That is the French alphabet for A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, R, S, T, U, V, W, X, Y, Z. So how can I use bilingual? I can use a decision tree to I can apply a decision tree in my training set that will be phonetic partite, bipartite. Yes, I can use the decision tree. Yes, there'll be bipartite. So a bipartite decision tree. Why a bipartite decision tree? What type of decision tree? A binary bipartite decision tree. Yes, decision tree way. If I can remember this properly, decision tree have decision bipartite will have two colorable graphs in it that will decide how the model and the Markov chain resolves the phonetics on how the phonetics of how words are sounded out, which is a phonetic word bank that maps real characters to real worlds. That'll be a chain of characters that match phonetics to actual characters in a language. And the bipartite nature of them is in one language, it can be either one word or the other, which will one word or set of words that will dictate the next word. uh, uh, one phonetic alphabet that will dictate the next set of term in the Markov chain. Uh, exactly. Uh, but the whole goal of this is accuracy, is precision, not accuracy, precision. So algorithms like A star and Dijkstra's should be used to score the nearest neighbors via breadth first search and depth first search. Or algorithms bidirectional Dijkstra or bidirectional A star. Because there's two words. The mapping of phonetics is bidirectional in languages. Am I talking trash? No, I'm not. How do I implement user history? I don't know. I've implemented one. So you have a word, I have a cost to a word, and the cost to a word in cost to next phonetic is as an edge. Should I prefer edge coloring or node coloring? Because if I use edge coloring, that makes more sense because they are being traversed. So edge coloring is bipartite, not node coloring. So for example, I color road red and color one green. How can I detect the right phonetics use is correct? Because the edge represents the closeness to the correctness of the word and the business scoring. And the system must respect these principles. So, um, so if I sound words out, how can this transcriber service accurately dictate build on my dictate phone? So I can paste this into a AI system, an AI building, and see what the AI can build. But I don't trust it because I want it to be able to dictate an entire book from this method of phonetically mapping alphabets. Yeah. The about the accent. No, that's B C B C. Okay. B. Oh, what's English up? D F G W H G G G G G G W H Hey E G K Li. Well, I'm stuck at G. I'm trying to recite the Igbo alphabet. Um, Decision tree can decide. But I've never seen one in my life. But it should design cluster data based on binary outputs. So bipartite nature of the uh, uh, because I'm trying to cluster the words into semantic like the tonal language instead of having another tone. So the tone can be low, high, and mid flat. High tone, low tone, and a flat tone. But this is a transcription service. So it's a transcription service that used to detect the language once you put a punctuation. So this has two parts: to punctuate or the lexeme, and to dictate the lexeme or the punctuation that are or the breadth or the port, which can use uh uh which I love this idea very much, which can use Morse code. So the Morse code for breath will dictate the punctuation, such as the comma, uh, in real time. So because grammar isn't fixed to the language. So basically, as I dictate, the computer will be able to use a Morse code like dot dash, dot dash dash dot, or I don't like the idea. I think it's not suiting into the framework of Morse code. Yeah, it does. It works perfectly with the Morse code because it's all you can have the alphabet in the Morse code too. But I want to make sure system isn't fragile. So I want to be able to dictate commas, which can be done by Morse code. So it's a perfect fit. So as long as I'm not overfitting the data set or underfitting, my model should perform as speech to text. So this is speech to text service that can dictate books. So write with your words, Namdi. Yeah. Can I put it up tonight? Yes, I can. Am I lost? No, I'm not. Who am I? Maybe how would I dictate a paragraph? Let's say example. The quick brown fox jumped over the lazy dogs. That should be a sentence that test hypothesis in old languages, but it's a machine learning model. Can I can I can I because I can dictate to my computer phonetically. Uh, but how would this wait? How would this train the data set? How would this work? Um, it should work, and I'm not worried. I'm not doubting it. It will work. Okay. Thank you for watching this video, guys. This is the next step. Build a transcription service that uses web interfaces, speech to text, to train a Python machine learning model to transcribe information using the data structures in the data set in this transcript. Let me just stop this. um, Thank you.